On this side of the worksheet where you had to figure out the function that matched this graph, in all of them, the first thing you should always try to locate would be the period and the shift up or down. So here we're looking at either tangent or cotangent. It really doesn't matter at this point which one we're going to use, but we need to find where the midline is, which would be at these two places. So there's our midline, which means it's shifted up 2. So no matter what we do, we know that this has to be plus 2 at the end. Then from there, if you're looking at the period for tangent or cotangent, it's always the distance between the asymptotes, which from one asymptote to the other, it is 1, 2, 3, 4 marks. So that would be 4 pi, and since it's 1, it is 1, 2, 3, 4, 5, 6 marks to actual pi. You're going to get 4 pi over 6. So the period is 2 pi over 3. So then in the equation, you have to figure out pi times what gets you 2 pi over 3. And x then would be 2/3. And so then remember, when you stick it in, substitute it into the equation, you have to flip that value so it becomes 3/2. Then the other thing you have to look at after that is what is the amplitude? And that would be halfway in between which this is the halfway point from here to there. How far is it? And it looks like it is down 2 and up 2. So therefore, okay, wait a minute now. This other drawing this one isn't the most accurate one, so we can't use that as far as our period is concerned. In this one here, halfway in between, which is right here, it's 1, 2, 3, 4 up, and halfway in between here and there, which is right here, it's 1, 2, 3, 4 down. So yes, now our amplitude is 4. On your piece of paper, the drawing isn't that bad. And so then, now all we have to do is figure out which one do we want to use. Because this one has an asymptote right at the axis, cotangent might be the one you want to use to begin with. Cotangent, though, when you graph cotangent, it looks like that, which is not what this one looks like. So therefore, we have to turn our amplitude to a negative. That will flip it to the way we need it to be. And then, because our asymptote is right on the axis, which is what cotangent usually is, we would be done with it. And we would just leave a -4 cotangent 3/2 x plus 2. Now, if you wanted to look at it and deal with this type of a drawing, that is tangent. And so the 4 would still be there, the 3/2 would still be there, the plus 2 would still be there. But now we have to move it, because tangent is supposed to start on the axis, but this one is shifted either to the right 2 places or left 2 places. So we could put x and plus and minus, it doesn't matter which way because it's the same distance on either side, plus or minus 2 pi over 6 or pi over 3. Now that's 2 pi over 6 because it's 1, 2 marks out, and pi is 6 marks out. So that's why it's 2 pi over 6, which simplifies to pi over 3. So here are the two different options you have to write that first equation. Moving on to our second one. Again, first thing you want to find would be, here's like the maximum of this part, and this line right here is the minimum, which puts the middle 1, 2, 3, 4, 5, 6, 7, 8, 4 away. Right here is your midline. And so that is up 1, so we know no matter what we use, it's going to be plus 1. And since this is 4 away and that's 4 away, our amplitude is 4. Now we have to figure out what is the period. And this is secant or cosecant, and we have to deal with one whole wave of it. That takes you from this asymptote all the way over to that asymptote. So then, counting this out, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pi. And normal pi is 1, 2, 3, 4, 5, 6, so 16 pi over 6, which simplifies to 8 pi over 3. So now we have to figure out 2 pi times what is 8 pi over 3. And that would be 4 thirds. So then when we put it into the equation, we have to do the reciprocal, so it's 3/4. Now then, there's a point and there's a point on our reciprocal function, which would look like this. And so now we have to decide, are we going to use secant or cosecant? If we use this as our starting point and have it going up and down, then we would want to put cosecant here. And that is shifted to the right, pi over 6. So we put x minus pi over 6. If we chose to use our other one and put secant in, none of that would change. The only thing that would be where our starting point is, and that is right here at this coordinate, which is 1, 2, 3, 4, 5 pi over 6 to the right, so then x minus 5 pi over 6. Or if you wanted to use this as your starting point, then you would have a negative 4 there, and this would become x plus 1, 2, 3 to the left, which would be pi over 2. Our next function. This one could be either sine or cosine. Maximum is here. Minimum is here. Which puts your midline at 4 away. 1, 2, 3, 4. There's your middle. And that is up 1, 2, 3, 4, 5, 6. So we know we have to have a plus 6 there. And our amplitude is 4 up and 4 down, so it's going to be a 4. Now we could use sine or cosine. We've still got to figure out our period, which we would count from there to there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our period is 12 pi. And pi is 1, 2, 3, so 12 pi over 3, or so 4 pi. So now 2 pi times what is 4 pi? And that would be 2. So then in our equation it becomes 1/2. Now then after that, you got to determine which you're going to use. If we choose to use this as our starting point so we can say it is sine, then it's 1, 2, 3, 4. So x minus 4 pi over 3. And if you choose to use this point as your starting point and want to use sine, then you would have to put a negative 4 in, and it would be left. So you'd put x plus 2 pi over 3. All the other values would stay the same. If you wanted to go with cosine and use either this point, because it starts at its maximum, then you would say 4 cosine 1/2, and then x, and this is 1, 2, 3, 4, 5, so plus 5 pi over 3, and then plus 6. Or you could use this point right here and turn this into, let's go with this point, negative 4 cosine 1/2, and then that is x minus pi over 3 plus 6. Moving on to our next one. Maximum is right here. Minimum is right here. So then our midline, 10, so 5 away, 1, 2, right there's our middle, which is down 1, 2, 3, 4. So we know we have to have a minus 4. Our amplitude, since it is 5 away, up and down, we know we have to have a 5 there. Period would be counting from this point to that point, which is 1, 2, 3, 4, 5, 6, 7, 8. So if 8 is halfway, 16 has to be the full length, so it is going to be 16 pi over 4, which is 4 pi. So the same period as our previous problem, so then we're going to need to have a 1/2 in there. And now, looking at the function that we have, we can use either sine or cosine. In this case, because it starts at our maximum, I would choose cosine. And then all you have to do is put an x, and you're done. If you wanted to use sine, it would be 5 sine. That would be this point right here. And then that is shifted to the left pi. So you would put x plus pi minus 4. And if you use the other point over here as your starting point, then it would be a negative 5 sine 1/2 x minus pi minus 4. Not sure why you'd want to use a negative cosine, because that would just be way too much work. All right, moving on. There's your minimums. Here are your maximums, which puts your midline right here at 1. So we know we have to have a plus 1. Period, our amplitude is 2. And now to figure out the period, you count from an asymptote or from a hump to a hump, which is 1, 2, 3, 4. So 4 pi over 2, because pi is right there, which is 2 pi, which we do not need to put any number in there because it's normal period of 2 pi. Then you have to look at one cycle of this to determine which function you want to use, which looks like this. And hey, it starts in the middle, except it goes down, so I'm thinking the easiest thing to do would be to put a negative in front of that. And sine starts in the middle and goes down, but because we're dealing with the reciprocal of that, it would be cosecant of x. And there you would have it. Now then you could also put in 2 cosecant of x, and then you could have plus or minus pi plus 1, because that would be this point or that point. And if you wanted to go with secant, it would be x minus pi over 2 plus 1, because that would be that coordinate right there, which is shifted left pi. All right, our last problem of the day deals with this one, which is either tangent or cotangent. First thing is, here is our midline, so that's minus 3. Figuring out the period, which would be the distance from here to there, because those are the asymptotes. 1, 2, 3, 4, 5, 6. So 6 pi, and it's 1, 2, 3, 4, 5, 6 to pi. So 6 pi over 6, or just plain pi. And since it's tangent or cotangent, period is pi anyway, so we do not have to put anything after tangent or cotangent. Finally, looking at an asymptote, which is right here, and here's the other one. If you go halfway in between the middle and the asymptote, it looks like it is up 1, so therefore there does not have to be a number out in front of tangent or cotangent. And so then this one starts in the middle, so because it's tangent usually starts on the axis, let's use that one. So tangent of x, but tangent looks like that. This is the flip of it, so then we just have to put a negative out in front of tangent, and we would be done with it. Now, if you wanted to use cotangent instead, none of that would change, except now we would have to shift it to the left or to the right, pi over 2. And that would get you some other options for this particular function. And that concludes this page of that worksheet.